And now sharing my screen. Okay, hope you can see my screen properly. And hello everyone. My name is João Martins, as most of you already know from the previous sessions. I'm a Forest Developer Advocate here at Autodesk, and today I'll be covering this bootcamp session with you. This is our last tutorial focusing on design automation, and for that we'll be using .NET Framework, right? This is how it works, how this bootcamp is working. We have 4 days of presentations going through our simple tutorials, our beginners tutorials, and each day we cover will be dedicated to a different tutorial. Today, as I already said, we'll be using the Design Automation API to modify designs and take advantage of the API of specific products available on our platform. We have simultaneous sessions for EMEA time zone and America's time zone. This one is for America time zone, and together with the divided in for each of these time zones, we have parallel tracks for .NET and Node.js. This one is focusing on .NET, so if you want to use Node.js, please go to the other presentation that we have occurring right now. And during the webinar, we are going to code, and you can submit your questions. If you want to submit questions, please use the Q&A. This way we can address the answers and everyone can take advantage of your request. Yeah, we have minor breaks. You're going to decide how many minutes we will have as breaks for you to perform the task that I'll be showing and to address any other issues or any other questions. I'm here to help you go through this tutorial and take the advantage of our APIs. This is what we had. On the first day of the tutorial, we built a simple viewer application to basically take care of the uploading and render designs on the browser. On the second day, we did basically the same, but this time connecting with one of our cloud products. I connected with Autodesk Construction Cloud, but you can do the same connecting with Vim 360 or Fusion Teams, for instance. Yesterday, the focus of our bootcamp was on creating dashboards and custom extensions and adding those to the viewer together, connecting with the model through the usage of the viewer API, right? And today we are going to cover what we call configurators. That's basically going to use one of our APIs, one of our engines available in the cloud to modify input files. And we support different engines, different products, as you are going to see in these sessions. So let's begin. Day 4 configurator, and this is the goal of the day. This is the goal of this training. Will be the quick sample that's going to take advantage of design automation to modify an input. In this case, we are modifying specific parameters of an input file, and it's going to change depending on the engine that you're going to use. I will choose the Rabbit engine for this tutorial, but feel free to go through it using 3ds Max, Inventor, or either AutoCAD. All of these engines are supported by our Design Automation API, all right? We are also have available on our user interface, on our application, the functions to manage how to upload files, how to download specific files, the management of buckets, that is the repository for storing these files, how to perform this task, use this automation against a file that is on local. In this case, we are going to upload a file that we have available on your machine, and we will cover the basic concept for design automation. In this case, we have a few keywords such as activities and bundles, but don't worry about that now. We'll go through all of that together in the next sessions. This is the agenda for today. First of all, we have the intro and setup. I suppose I'm not will be taking the 30 minutes. We might make it shorter. And after that, we take care of the basic server and user interface. Then we take care of the plugin and app bundle. I will talk to you what is the plugin, what is the app bundle, the difference between those. And last but not least, we'll take care of the activity and the work item. Once more, you are going to decide how many minutes we'll have between sessions, or if you want to go and skip a break between sessions. That's entirely up to you, the way you prefer. We'll simply go through it. And first of all, we have the introduction and setup. Before we jump into the introduction, into building our sample, it's good to have knowledge of the key concepts and what is design automation, what we're going to be building in specific terminologies, what is exposed and not. First of all, a word on design automation. Design automation is our API that run automations on your design files. Pretty obvious based on the name, right? We have design automation is available as of now for 4 different products. So you can take advantage of design automation to modify, to take advantage of an API for a Revit file, for a 3ds Max file, Inventor file, or an AutoCAD file. You can take advantage of those 4 products APIs, right? And you have a beta for Civil 3D included in AutoCAD API. Right? If you have basically how to know when I'm going to use or when I can use design automation. Basically, if you have a plugin for any of those, you should be able to convert it to run on design automation. The main difference here is that we can take advantage of the user interface at runtime. If you have a plugin for any of these products, you might be using a user selection or a query based on the user interface based on, you might take advantage of a user interface or so on. As we are running everything on cloud without the user interacting with the engine, we can take advantage of the user interface. So basically, repetitive tasks that don't require man hours can be automated with design automation. If you have an input that only needs to be passed one time, just like the sample that will be today, is a good case for design automation. For instance, if you want also to update specific versions of one of these files, you can do that by design automation. If you want to batch processing multiple files to generate PDFs based on views of Revit files, for instance, or based on the DWG file, you can run that on design automation, and you get free of the required man hours. You won't have a bottleneck based on the necessity of an end user performing those tasks through the interface of the product itself. This diagram here is really useful because sometimes people make confusion on how it works. It is important to make clear that the REST APIs that we are going to use today for the design automation API are not exposing directly our products APIs. So for design automation, you are not directly calling using the Revit API or the Inventor API or the AutoCAD API, 3ds Max API. In fact, we have what we call an app bundle. The app bundle is your code, your logic, your algorithm using the product API. I can have an app bundle using Revit API, for instance. We have a question right here. I thought Fusion 360 would be the most natural selection for the engine on the cloud. It is still not available. Any plan to add it or Maya? I can check that with my team. But you might be able to take advantage of Fusion data. This is not covered on this tutorial, but I will point you to Fusion data APIs that we just released a few moments ago. It is a different concept, but yeah, in the future we should add possibilities for creating information and information for Fusion 360, and also Maya. I'm not sure about our how is on our roadmap, Maya, but I will ask also our engineering team to answer your question. Thank you very much, Navid. I will post it here. Your address your questions. So, all right. I was talking about the app bundle. App bundle is your code, can be your logic, for instance, to modify parameters on the file or do basically anything supported by the API. And this app bundle is going to stay on our server interacting with our product. You provide the app bundle and upload it to our server. Let's speak of Revit, for instance. When you submit a work item, a job to execute on design automation, it will start on the Revit server, on our server, and you take your code that you made available. From there, you can take advantage of the specific API of Revit to open supported files. Then you can read, modify, generate reports, export, anything supported, except but user interface. All right. This code will be on the app bundle right here under my code. So your code will run on a sandbox environment on the cloud using a Revit server that we have. All right. What is exposed through the RESTful calls in Design Automation API are common methods for all of the supported products. Common methods for to define, for instance, how your job is going to execute, to define how many inputs, how many outputs, to define the execution of the job itself. But we're not going to directly through Design Automation use the API of one specific product. That is done through the app bundle. All right. And another key concept, important concept, is that this service can be used by any app, from a website, desktop application, or either from a mobile app, right? Now let's take a look at the workflow for Design Automation API. First of all, you have your Forge app with all of the definitions referring to a specific engine API. We have all of those available. All right. And we also need to specify the source data that's going to be used to extract information, to export a view or anything covered, right? With that combined, we are going to submit a job to Design Automation. And Design Automation is going to process these definitions against the source data that you provided. After the execution, we can generate modified data that's covered on the tutorial of today. We can also generate reports based on for text files or anything that you prefer on your logic, on your workflow. And we can also have different outputs. Revit, from a Revit file, I can generate an IFC, or I can also generate from DWG or Revit file a PDF based on the views that I have available, and so on. This is similar to batch processing. We have an input, a process, and an output. The workflow is the same for all the four engines, right? It's also important to specify how the data is used on the cloud for Design Automation on this sandbox, on this common folder that's going to run your algorithm, your logic. All right, it is your data, and it doesn't matter where you store it. You just need to make this data available in the cloud so Design Automation can take advantage of it. This data can be from on Azure, can be on Google server, can be on AWS. And by AWS, I mean either the Forge bucket managed AWS, Forge bucket manages, Forge managed bucket, sorry, or the bucket managed by your AWS account, can be on Dropbox, or it can be either even locally available, just like we are going to use today. After that, you need to you need to provide send downloadable links so Design Automation can take advantage of this data. The first thing Design Automation is do when you submit a job is download the input data that you have. Then after that, Design Automation is going to run your code against the data that it downloaded, and it's going to upload the results via web request to the upload to the storage that you defined. So if I want to use this storage that you define for the upload is also on the cloud and can be any one of the supported, can be any storage on the cloud that you made available. You just need to provide on the execution job inputs to download and a URL sort to download and a URL to upload the result. And after that, it's good to inform, always good to know that your inputs and output are not stored. They are only downloaded, processed, and discarded. Both the input file and the output file are not going to be stored by Autodesk by any way. They are just used and then discarded right away, right? They are just going to be accessible on the storage that you defined. Okay, and just like all of our APIs, design automation has some specific terminology that is required. We need to understand this terminology in order to take full advantage of our API, of how our system works. First of all, we have our engine. Engine refers to the executable used to batch processing. It is the Autodesk product, including the specific version. We can have AutoCAD version 2022, AutoCAD version 2019, Revit version 2023, and so on, Inventor 3ds Max. We can specify the engine and the version that we are going to use to process our input and generate the outputs. And those versions will refer to the API, the versions of the API that are going to be used, all right? With that, we need also to specify an activity. The activity specifies how and what it will execute. It specifies the number of inputs, the number of outputs, which app bundle we are going to use, how many inputs, are those input Revit, are those inputs, zipped contents, are those inputs generated on demand, are there required additional parameters? Is there an input that is not really necessary? Are you going to use a template, something? Everything, basically, the tasks, the description of the parameters, inputs and outputs are described in the activity. We also have the reference for a specific app bundle, right? And together with that, we also need to specify which engine we're going to use. Now we need to know what is an app bundle. The app bundle is the task that's going to be performed. It can be used as a plugin, an add-in, a script, etc. It is basically a module referenced by an activity in order to perform specific functions, right? Combining both an activity and an app bundle, we have the work item. And the work item is the submission of an execution job. So activity, app bundle can be defined only once. They are defined once. The activity is the definition of how many inputs do I need, how many outputs are going to be generated, are they required or not, I need additional parameters, which app bundle I'm going to use. App bundle is the code, the plugin. And combine those, I can run this activity against multiple different input files, generating different output files, different reports, or different extractions, right? Putting it together, activity defines what to run and how to run. Work item is a job that executes an activity, and the engine process the activity with the app bundle. Correct? We'll go through that in details on the next sessions of this tutorial, so it will be very clear. If not, just submit a question. So the logic, we have a question right here. So the logic on our app bundle should be designed to run on a single file only, and then in the activity we specify that we want to run it on multiple files. In other words, the logic in app bundle shouldn't try to manipulate other files. No, the logic on our app bundle can load multiple files. For instance, the activity is going to define the input. You can have, for instance, an app bundle that uses an input file, a Revit input file, go through all of its views and generate PDFs. Or you can have an app bundle that go through all of the Revit files available, go through each view of these Revit files available and generate PDFs. That bundle should be designed to work on an input. It can be multiple files or one single file. It's not necessarily only one file. You can either start without an input file at all. You can do it based on a template. It's just the code that takes advantage of the API itself. If you have a plugin, if you have an add-in script, it's just like that. It's a plugin that runs using the API. The activity is going to define the inputs, outputs, and the parameters, right? We will see how it works in the, I guess, in the third session of this tutorial. So I hope it to be clear. All good, Zachary? You can use the chat window or the Q&A, but let's continue for now. We have a few prerequisites to perform to build this sample today. One of those, of course, is the Forge account. If you don't have a Forge account, you can create one. As soon as you create your first Forge account, it will be submitted as a trial account where you have 90 days with enough credits to access all of our APIs, to test all of our APIs. Inside the Forge account, you should create the Forge app. The Forge app, you have the credentials, the client ID and the client secret that will be used to grant access to Forge services. All right. A quick question here: do I need AutoCAD, Inventor, Revit, or 3ds Max? For now, no, because this tutorial will not go through the details of any of these specific products APIs. We are just going to download the app bundle already built and just going to use on the web application. But of course, for later, yes, you need these APIs, these products to develop and test your own plugins. On your workflow, you have a custom plugin, so you need to develop this plugin and test against source files and validate it. So for now, you don't have to worry about it, but when you want to release a product to build your own plugin, you will need those products, right? The development environment, we are going to be using .NET. So we use Visual Studio Community. If you came from the previous tutorials, we used Visual Studio Community version 2022. We are migrating this tutorial to the newest version, newest framework. So the first ones were already using .NET 6 and Visual Studio Community 2022, but these one haven't been migrated yet. So for this tutorial, the documentation is based on the Visual Studio 2019 template and also using the .NET Core 3.1. But it works the same. It will work if you use the Visual Studio 2022. You just need to use the .NET Core 3.1. That is required, all right? We are working to migrate those. So I have both installed here. I'll ask you to please let me know through chat window if you prefer to use Visual Studio 2022 or 2019. Just drop it on the chat window and I will use the one that you submit most. 2022. Those that didn't comment, you still have time, so yeah. And also, the way design automation works is that as soon as we submit a process to be a job to be processed against, it's going to be enqueued. The input file is going to be enqueued together with the task, the bundle, the activity that we defined it. And then it might take some time depending on the queue that we have at the moment and depending also on the complexity of your app bundle, what it is going to do, if it is too much process, and the input file, right? After that, It's going to generate the result, upload it, and send a notification that this job is already done. To send this notification, design automation needs a callback, needs an endpoint available through the web to send the response, to send the result. Oh, your job is done. You can take advantage of the result right now. As we are not deploying our application just for this phase of development, we need to expose our endpoint to the web. And that's done through this tool called ngrok. So we are going to need that for this phase of development. As soon as you deploy it, you don't need ngrok anymore because your endpoint is going to be accessible through the web. All right, let's go. Enough talking. I spoke too much, but you made good questions. Thank you for that. First of all, let's take care of the prerequisites, the creation of the account. I already have my account here, so I'll just sign in. If you don't have it, just select create account and it will create. But for that, you need an Autodesk account. From an Autodesk account, you create a Forge account. As I already have it here, I'll just submit, enter my login, my email, and my password. And right now we should go under the applications. If you are creating this for the first time, it's going to be an empty page, but I already used this application a few times. I have all of my apps that are created available here. So right now, I'm just going to create an app. Let me call it Bootcamp 2022, day 4. And as soon as we create it, we receive the credentials. The credentials are required to grant access to our services through this account. And it's also going to create a random callback URL. We are not going to use that today because today we'll only use the two-legged token. But to understand more about the callback URL, the three-legged token, go to the tutorials on the go to the tutorial on the second day where we connect with a specific hub. Here, right below, we have the control over the API access. I'm going to let everything selected as I'm just developing a solution, but for production, limit to only the access that you require. The sample is going to use data management because this is going to take advantage of buckets to store our files. Remember, the files need to be available in the cloud so Design Automation can download and upload. So for this sample, we'll be using Forge managed buckets. And this, of course, it always also needs the Design Automation API. So we have everything prepared in regarding the Forge part. Now we need the Visual Studio. So we can download the Visual Studio. Let me find the link to download it. Yes, this one right here. Visual Studio, this case, Visual Studio 2022, it is the current. If you want to go with 2019 right here, and for 2022, this one. As most of the people asked for 2022, I'll go with this one. And ensure that you need to ensure that you have the workflows for ASP.NET and web development and .NET desktop development. .NET desktop development is useful today because if you want to compile your plugins, remember the plugin is going to be a DLL based on the API of one of our products. So to compile that, you need a .NET desktop development and to compile and to test it with one of our products. As soon as you have it, you should be able to check it right here, just like I'm doing right now. I'm going to continue without code. If you take this moment to drink some water and ask your questions if you have one. Zachary, is it clear the logic that you can use multiple files on design automation? We are going to check an app bundle. If it's not clear, please, you can also use the chat window. We can check through get tools and features. And these two workloads right here. It is important Portuguese, but the UI it is the same. Web development and desktop, right? For this tutorial, again, we'll be using the .NET Core 3.1, but soon we'll be migrating to .NET 6. And this is the tutorial that we're going to build today. If you go to the create a server, the first option right here, we can see the prerequisite, the ngrok. So go over there. Let me post this link to everyone. This is the link to download the ngrok. So download it, as this is going to make, we are going to use it in order to receive the notification from design automation. Once with that, with ngrok, you should be able to use this command right here, ngrok, under the command prompt, in order to create the tunnel, right? This is the address that we're going to use. I have an account logged in, but my plan is free, so feel free to use the same. But yeah, that's what's requested for this time. Let me just cancel it, so as we're not going to use until the last session of our tutorial. Okay, quit, and that's it for now. After you have all of those, we can keep going with the basic server and user interface. Zachary is mostly clear. I'm just wondering how it would look in the plugin code to reference other files. With AutoCAD, you can open other files outside the place format the specific file path. All right, you can have as the input a zipped folder, and inside the zipped folder you could have the multiple files that you have, or you can use the from the input folder that you have a library, a method to go recursively through each of the files in that zipped folder, and that's going to be the input. This is one way to do it. I'll check. Adonagi also added a blog on that. Let me check that for you. We also have the on-demand callback. Let me just find it. Autodesk Forge Design Automation. I remember Adam added a blog on that pretty recently. I'll find it and post it so we don't have to count our time for the tutorial. So for now, how many minutes do you need before we build the basic server and user interface? Oh, no worries, Navid. You can reach us using the forge.help at autodesk.com. Good to go. What about the others? Yes, the cost is based on processing hour and not per file. Model derivative is per file, and design automation is depending on the cost in hours. we have a calculator. If you go on the Forge calculator.autodesk.io, you can specify your job, what you're going to use, your workflow, and take advantage of this to test, to have an estimation on how many credits you will need. This is an estimation. The best way to know for sure how much is going to cost your process is to build your sample and test it against different files, so you have a better benchmark to go for production. But in here, for instance, I want to modify a model. This is an AutoCAD engine. The model size is 100 kilobytes, so it's an average complexity, and I'm going to use it 4 times a month. So 6 seconds is the estimation for this kind of job. 2 credits for hours. So each month I'll have 0.1 cloud credits consumption for this specific task. Let me copy and paste this to you and paste it to the chat window. What about the others? Do you need a break or can we go? Post a reaction like this, like thumbs up, if you want to go, please. If you want to continue without a break. All right, then. I don't I don't have much answers. So let's do like this. 10 minutes. Sounds good? All right. Zachary Tyler, can I see you in 10 minutes? Let's give, sounds good. All right. So 10 minutes for people to take care of everything, Visual Studio and Rock. And then we go back to the second session, right? See you in 10 then. Let's continue the recording. Sharing my screen. And before we jump into the second session, let's go through one detail. We had a question from Zachary, hoping I say your name properly, about different number of input files, not only one input. Please go through this blog post right here. It shows the different options that we have for that. And the one I specified through the zip input, it was this one, this first one here. You can also take advantage of the on-demand callbacks, described here, using on-demand parameter, and so on. So I'm just going to post it here, and it shows the possibilities for using multiple input files. All right, and with that, we can go to the next part of our tutorial. All right, now let's cover the basic server and user interface. Again, this is the architecture. Use this diagram to show the architecture of our applications, our simple applications. We are basically going to store our credentials from the Forge app. Again, our credentials grant us are what grant access to our services, our APIs. So store those as environment variables on server side. The client side can access those credentials, and all of the communications, all of the requests are made through the client, through the server side. We are going to build an interface, the client side, and through this interface, the user is going to click through buttons or through inputs. It's going to select perform actions that are going to connect with the server side, and the server side is going to perform the request to the Autodesk Forge server. Then it's going to return the responses, and then we are going to add those information on the interface on the client side. All right. The only difference in this case is that for the work item, for the job being executed, the app bundle on the virtual machine will have it will take some time to render, and it's not a simple HTTP request. When you send a request and grab the result. So this automation is going to grab a input file that we specified, the activities, the app bundles, perform the job, and as soon as it's done, it's going to send a notification to our server side. So from this point, we are going to need to, from the server side, send a message to the right client side that started this task, that started this job. To use that, to do this communication from server to client side, we are going to use SignalR, the SignalR package. SignalR package is to handle this type of communication. All right, we have a package on client side and on server side. We are not through this application, we are not using viewers, so we don't need to generate a public token that's going to download the result from the client side. If you want to see the results, you can see through viewer.autodesk.com, or you can also use one of the samples that we built on the previous days of our tutorial. This is what we're going to do now. Create a new project using ASP.NET Core. The version will be .NET Core 3.1. Set up the environment variables and create the basic server and so on, and the authentication controller. After that, we are going to take care of the basic user interface through the HTML and JavaScript files. Right? So let's go do it. We already downloaded ngrok. I hope you have downloaded successfully. And now we need to create a new project using .NET Core 3.1. It says 3.0, but let's use the long-term support version, 3.1. This sample will be building with the name of Forge sample, but we can do it with the name that we choose. We just need to go under create new project right here. And the template, if you go to this tutorial, it's quite old. So it's using a template that I'm not sure if it's available anymore, ASP.NET Core Web Empty. So let's go with this ASP.NET Core Empty one right here. It's the same one that we used in the previous days. So now we click next and we select a name for our project. Let me call it Bootcamp. Day 4. This is my third day of tutorial, but it is the fourth one actually. Let's create it. I placed the solution and the project files in the same directory. In here, remember, we are going to use the .NET Core 3.1 because it's the one our tutorial is validated. And unmark this option, configure for HTTPS, to simplify our development. We are just debugging. We are just developing a sample. And now click on create. It's going to take care of everything. I'll take this moment to drink some water, and if you have some questions, any question, this is a good time. Let me try to change my camera. Last time I tried, my camera was not working. Yeah, the same. So you need to keep seeing me like this. Sorry for that. So all right. Now we need to take care of our SDKs required for this application. We demand different SDKs this time. The first one is the Autodesk Forge. We used this one in the previous applications that we built. So the steps to add is we go under the project name, right click it, select the option Manage NuGet Packages. Now we go under browse, paste the name, Autodesk.forge, and this is important. We need to use the version 1.9.3. Why we need to use the version 1.9.3? Later, when we are going to handle the upload of the input, upload of the output, managing the buckets, we have a new method for binary transfer. It's called direct to S3. And this new SDK takes advantage of this new method. And the tutorial is using the new method. That's why we need to use the version 1.9.3. I'm sorry for that. I tried to mute it. I was not fast enough. Now let's click on install it. We need to accept its dependencies. Okay, here it is. Now we take care of the other SDKs. First of all, first one, design automation. And this time for this next SDKs, we need to always use the version that is compatible with our framework. As we are using the framework version .NET Core 3.1, we always need to add a version compatible with the .NET Framework version 3. So we can paste this name right here, add this design automation, Autodesk for design automation, and change this version. We are not using the latest. We are going to use the 3.0.6. Install it. Okay, it is right here. And now the same for Newtonsoft JSON, useful for handling JSON data on our application. Once more, this is when we want to use the .NET 6. For .NET Core 3.1, we go with this one right here. I guess this is the most recent one for .NET Core 3.1. Yeah, it is. So having trouble with my mouse. Okay, install it, accept its dependencies, and it is good to go. And the last one, SignalR. Once more, SignalR is the package to manage the communication from server side to client side. The version compatible with our framework. And I see we have a question. Okay, we accept its dependencies. Let me check. But we are only using .NET because that's a tutorial is written for. Exactly. We are using the .NET Core 3.1 only because the tutorial is desired for this version. If we use the .NET 6, it might have some incompatibility, so we will need to keep debugging and see the difference. Maybe on these versions right here, they had some different behavior. So to avoid that, let's keep the same version that we have on our tutorial. And with that, I also need to say that we are working on submitting, on publishing a newer tutorial on design automation using the .NET version 6. Insert live. Okay. Now let's go back. We have all of our SDKs that are required. Now it's time for the environment variables. Environment variables. Here we have another change. As this tutorial was built for Visual Studio 2019, the interface changed. I don't know why they did it, but it's quite different. So let's use this ASP.NET, ASP.NET Core URLs. Let's add the environment variables. We can go under debug, debug properties, and in here we have the environment variables. It's quite different. So we need to add the environment variables using comma. So we say specify comma equals, and the value would be HTTP localhost port 3000. And for some reason, we need to also double the number of bars. This I went through while debugging. For this interface that we have right here, you need to double the number of bars. The other environment variable is our Forge client ID. So let's add Forge client ID, and the value will be the one that we got from the app that we created. All right. Now the next one is the Forge client secret. Forge client secret. No, I'm gonna go here. Forge client secret. This is the value of my client secret for my application. And also we need to specify the Forge webhook URL. The Forge webhook URL is the one that we get from ngrok. I haven't started, but you can start using this command right here. Let me paste it so you have it. Let me paste it on the chat window so everyone can see it. And this is the address that we have. We are just not using this S, so we can't. In my case, I only got one. If you have a most recent version of ngrok, I guess it breaks into two different URLs. So I just remove this S right here. For debugging, we haven't enabled it, and we need to also double the number of bars. And it should be good to go. Now we need to disable SSL. Use SSL is already disabled. Okay, so yeah, we should be good to go. After that, we need to manage some modifications on program.cs. So we need to first of all add these namespaces. Let's go on the program.cs and add these two namespaces. Namespaces for our just added SDKs, and also replace the content on the main method of program.cs. So main method, we just remove this and add those to add the design automation to our services within the configuration, the environment variables for the Forge app for our application. Now we need to perform some changes under the startup.cs of our application. Almost clicked on the VS Code. First of all, we need to add sorry for that. We need to add this namespace for MVC, model view controller. And we need to replace the content of the startup class with the one that we have here. This is to handle our static files routing using a model view controller, and also we have compatibility through the Newtonsoft JSON library, and also adding support for SignalR on our application. SignalR to handle the communication. So it is the configure class, the configure method, sorry. So it is right here. We get rid of this one. copy and paste this content. Oh no, sorry, is the whole class. The whole class. All right, now we have the proper configure service and configure method to handle our static files, right? Okay, and with that, we took care of the problem.cs and startup.cs. Now we need to add our authentication controller. All right, authentication controller, once more, is where how we grant access to our APIs, to our services. Our platform uses OAuth 2 for managing the authentication. You can check that through our documentation. It's always good to reference the documentation. Here we have the authentication part. And here we have, for instance, the tutorial, the steps by steps to get a two-legged token. We'll be using the two-legged token to perform all of our authentication in this sample. We're basically going to take advantage of the client ID and secret, exchange it for a token, and once you do that, this token is going to be valid for 1 hour. After this 1 hour, we just need to generate a new token and keep doing that as soon as the token is not valid anymore. To control what we can do with a token, we have what's called scopes. The scopes defines what this token has access to, which APIs, which tasks he can start, and so on. All right. Back to our tutorial. We need to create this controller under the controllers folder. As we started with an empty template, we don't have the controllers folder yet. So let's right click on the project name, select add, new folder, and call it controllers folder. Inside this folder, we are going to add the OAuth controller.cs. Let me copy this and paste it. Add controller API controller empty. This is the value of controller. And this is what we'll keep doing a lot today. Get rid of the content from template, copy and paste the content from our tutorial. As you can see here, we are only acquiring the internal token because we are not sending a token to the client side. We are not rendering files here. We are not rendering viewables here. So we are just using the server side to perform all of the tasks. We grab the file from local, send it to server side upload it, and perform all of the tasks to control the activities, the app bundles, and so on, and submit the job on design automation. Here we are defining the scopes. As you can see, we have lots of scopes for this token. We have the bucket scopes defined right here. And why we need those? Remember, to run a job on design automation, we need to make our input files accessible on the web. And we need to also provide a URL so design automation can upload the results. We are using the Forge managed buckets to do that. So our file is on our machine and we upload it to a bucket, generate a URL so design automation can download it, and generate a URL so design automation can upload the result. Send all of that to the work item process, and send us back the resulting file. For that, design automation needs to have access, our app needs to have access to the specific bucket. And in this sample, we are creating a bucket with some common name that's going to be used only on this workflow, right? All right, we have that sorted. Now we need to take care of the basic user interface. And for this user interface, we are going to have the HTML file and the JavaScript files. Let's go. We are going with .NET Core. So under the W root folder, we need to create the index.html file. We don't have the W root folder. To create it, we simply right click on the name of the project, select add new folder, and type www root folder. As soon as you create it, it's going to change the icon. This is because this is a common folder for static files under .NET projects. And now inside this folder, we are going to create the index.html file. So let's go, right click under the W root folder, select add new item, HTML, paste the name index.html. Once more, what we already know, get rid of the default content, copy and paste the one from the tutorial. Let's take a look at our HTML, at our page. We have some common packages that we use for this sample. We have the jQuery to simplify our request. We are not using it anymore. We are using fetch on our newest samples, but as this is a legacy sample, we was using jQuery. We also using Bootstrap, and here we have the library for SignalR on the client side that is necessary, and also a logic for design automation on the client side. That's done through this JavaScript file right here. We have a navbar on our application, and this navbar will contain the image of Autodesk Forge. If you want, you can change the source here to any image of your company, of your preference. Feel free to do that. And we have a model. This model will control the configuration of the app bundle and activity. Remember the prerequisites? We have the engine. With the engine, we need to create an activity. This activity is going to point to one app bundle available. And with all of that, we can submit multiple work items, right? The configuration is done through this model right here. Right below this navbar, we'll have the content specified mostly on a row on our page. And this row will contain two columns, one column with size small 4 and one with size small 8. The biggest column will be containing the output, the log that our end user will see. As soon as the user performs any tasks such as creating an activity, adding the app bundle, submitting a work item, grabbing the results, downloading the resulting file, everything will be added as a log on this element, inside this element right here, right? And at the left, with the smaller column, we'll have the inputs that we define. We have an input to specify width, an input to specify height, and also we have an input for the file that we are going to use, and a button to submit the work item, right? Just to emphasize, this sample is going to modify the parameters of a source file through design automation and generate a resulting file. Here you have the model to define the app bundle and activity. And in this model, we have an option, a select element that's going to show to us all of the app bundles that we have. You're going to see how we're going to add app bundles in the next session. We have also an option to show to the end user all of the engines available: Revit 2021, 2022, AutoCAD 2019, and so on. And we have also a button, two buttons to clear the account that we have. Clear account is basically going to erase all of the activities and app bundles that we defined. And we also have also an app bundle, a button to create the activity and the app bundle, right? This is what we'll have on our page, and it's everything necessary to start a design automation job. Now we need our JavaScript logic for design automation. And this is done inside a JS folder inside wroot folder. So let's create this folder first. We can just right click on the wroot folder, select add, new folder. Let's call it JS. And inside this folder, we are going to add the Forge Design Automation.js file. Let's select, right click the JS folder, select add new item. Java is enough. We paste the name from the tutorial, Forge Design Automation.js. And now we copy the content from the tutorial and paste it on our sample. Let's see what we have here. As soon as the document is ready, we are going to call this method prepare lists. What this method is going to do is that it is taking advantage of this function. This is a common function to erase the content from a select element and input the values that we get from a specific endpoint. Prepare list is going to update the current activities that we have for this endpoint. It's going to update the current engines that we have for this endpoint, and it's going to update the app bundles that we have available for this endpoint once more. All right. As of now, we don't have a controller for that. We only have the controller for authentication, so we can't really use it, but we will be improving that throughout the sessions. We also have right after the preparing the list, we are adding event listeners, sorry, for each of my actions. To clear account, the button to clear account, the action to define an activity, the activity modal, the action to create an app bundle and activity, and the action to start a work item. Let's see those. Clear account is going to clear the existing activities. Every time we select an option, it's going to this option here is going to ask for confirmation. If we confirm that we want to clear the account, it's going to reach this endpoint to delete all of the available activities and app bundles. Define activity model is going to show the model for defining activities and app bundles. The create activity and app bundle method is going to create both the bundle and the activity. It's from the button. This is called from the button inside the model. Right here, this one right here, create update. So in this case, we are going to start a connection. And why does this start the connection? Start connection is going to start a connection between the server side and the client side using SignalR. Through this connection is how we can send message from server side to client side, right? As soon as this connection is done, it's going to, create activity and app bundle. As soon as this connection is done, we are going to write a log that we are defining the app bundle, and we're going to call these two functions right here. First of all, create the app bundle. That's going to create the app bundle based on the selection that we made on the select element through this endpoint right here. As soon as the app bundle is created successfully, we are going to call the callback, and the callback is the function to create the activity. You can see this is passed as callback. Activity is just the same. We are going to use an endpoint that's not defined yet and grab the value that we have for the local app bundles from the selected element and grab the value for the engine that we specified, create the activity. After we have successfully created this activity, we are going to pass to reach the callback function. And as callback, we are going to prepare the list once more. This is the first method that was called as soon as the document is ready. So what's happening here? As soon as we create both an app bundle as soon as we create the app bundle and the activity, we need to refresh the list of available activities that we have, because we have one more. So that's why we are calling once more the prepare list function. It's going to refresh everything to the end user, right? Right, define activity model, and now we have the method for a start work item. Right below, right here, the start work item is from the button that we have on the left side of our application. It is right here under the small file, start work item, this button right here, and it's going to use everything that we defined. The inputs that we defined for the parameters required is using the connection ID, the activity ID that we selected, and the input file, everything, and start the work item through the usage of this endpoint right here, right? That we are going to define also in the next steps. Right here below, we have the function that's called start connection. As soon as the document is ready, we are going to call it without any callback. And this function is just taking care of starting the connection between the client side and the server side. This connection, once more, use it to make the communications from server to client side. This write log is going to write the information that we need on the client side, so the end user can see what's happening. And in here we have two listeners for this signal R connection. One listener for this download result, and this download in this case is as soon as a job finishes on design automation, we are going to pass the URL so the user can download the resulting file. And this is going to be passed through the connection right here. And we also have the onComplete callback. As soon as this job is done, it's going to send a message to server side containing the information about the time it wasn't queued. We have a queue on design automation for each job. The time, exact time where it started to being processed, and the time it was downloaded, and the time it finished, and also the status. This job has succeeded or has failed. We also have, for each job on design automation, we have a log containing all of the informations at the virtual machine level. So for instance, in your app bundle, if you write a console.writeLine and add information in different steps of your execution, those will be available in the log that is specified through this onComplete callback. You'll see that in details. You'll see the full log described inside the application as soon as you start it. And that's it for now. Now we can see our application with a user interface completely broken because you don't have any controller for any of these methods that we went through. But yeah, we have a user interface, and that's a good way to check if we have everything correctly set. Oh, I take this time to drink some water. Navid, I'm not sure if Navid is still here. Let me check. I guess not. He said he wouldn't be able to stay here. Yeah, but I asked his question about if we are adding Maya when we're adding Maya. No, come on, let's go. Oh, he's already here. Okay, so this is our interface, the inputs that we have, the file, the parameters, the activities. We can't list it because we don't have the endpoints to grab the activities available. We have a model right here. This is the model that we're using to specify the app bundle, the engine, and create the activity or update it. We don't have anything to show because we don't have the endpoints yet. That's going to be done on the next session, right? So far, do we have any question? And good to remind, ngrok keeps running, right? With the free tier, if you don't log in, it's going to be available for 2 hours. After 2 hours, you need to keep refreshing. With the paid tier, you have more time, but yeah, we're just developing. We're not using ngrok at all, but so yeah, it's good to go this way. Any question? Are you able to perform these tasks? If so, what about a break right now? How many minutes do you want? 30 minutes, 15 minutes, 10 minutes, or want to go straight to the plugin or app bundles? Please submit your options. 1 or 10 minutes. Everyone agree? Please send some reactions. I need to at least, I don't know, a few people to send reactions or agree with 10 minutes. 10 minutes is good. All right, so yeah, you have to take care now of the, let me share my screen. Yeah, you have to take care of this basic server and basic app user interface. And after that, we take care of the plugin and the app bundle. See you in 10 minutes. And if you have any questions or any problems, just submit through Q&A or chat window. See you. Recording. Share my screen here. And we have a question. The question is from Tyler. First of all, I have the answer for the question from Navid. No, we don't have Maya on our workflow. Sorry for that. Not workflow, on our roadmap. Just send a message. And Tyler, should we be adjusting the debug launch profiles in IIS Express or our Forge sample project? I guess that this one right here, right? We have these launch profiles right here. I used the IIS Express, this one that I updated, and through the environment variables, I added everything, and this is the one I'm using, all right? If you want, you can create another one or use this one. You should have the same. I'm not using any command line arguments, so yes. Here we have a better interface, right? The name value. Just to be just like the one I did, add that to IIS Express, right? So I already debugged this through this, and I know the fails that it shows when you don't duplicate the number of bars, for instance. But yeah, it should work the same. I'm using the IIS Express. Answer your question. And now, if you don't have any more questions, let's see with 10. No questions. Okay, so let's begin with the third session of our tutorial. Is already recording. All good. Now we'll take care of the app bundle and the plugin of our application that our application is going to use. We are going to add them, and we also are going to reference the creation and definition of those. Right? In this task, in this session, we will prepare the plugin. In this case, as we are not focusing on the definition, on the compilation of the plugin and testing for a specific product, I will ask you to download one that is already available, that's already done for this tutorial. And we are also going to add the logic for creating the app bundle. Let's go do it. And it is right here, prepare a plugin. All right, a plugin, design automation uses the .bundle, a .bundle folder, just like the Autodesk App Store. It is described right here. It will contain the package contents.xml file with the definitions of the versions of the product that's going to use and so on. And it also contains a folder called contents. And this folder will have the DLL with the logic that you specified, the compiled DLL with using the API, and we have all of its associated files. For a Revit file, we have also the adding, the adding file with all the definitions on how the plugin works, what it is based, and how it's going to be understood by the uh, by the engine itself, by the execution of the engine itself. We'll also have you can also add DLLs with the dependencies of your plugin. In this case, for this plugin, we also have the Newtonsoft JSON, if I'm not mistaken, right? This content should be compressed. This tutorial is saying to use 7-zip, for instance, to create. And if we go under one of the plugins available, let's go to the Revit one. It shows all of the steps for you to create a new project, for you to which template you should use for creating your bundle. We have the namespacings, the libraries that are required. We have these Autodesk Force Design Automation, for instance, the command.cs with all of the logic for this app bundle, how it works based on the Revit API, the package contents.xml, and so on. And also it contains post-build events. So in a way that as soon as you compile this plugin, you build this plugin through this command right here, it's going to take care of copying the DLL and the contents required and adding everything together inside putting everything together and zipping it to generate the app bundle ready to be used by design automation. All right, I'm not going through it, as also I don't know if all of you prefer using Revit, so you can just download the bundle and skip this session. Later, when you have more time, you want to go further, you can go through these steps right here. And we also have different lightning talks. If you go under our platform, the session of lightning talks, we have different cover different subjects, different methods described here. WebSockets for design automation, we have data connector, and for design automation specifically, we have the design automation basics, is always good to check, and we have design automation in the context of the different products. Let me check. Design automation for Inventor, for instance, and if you load more, you'll see the one for Revit and AutoCAD, for instance. All right. For now, let's download the app bundle. It is right here. Oh, I already downloaded it yesterday when I was testing this. So let me just, I already had it here. Let me just delete this one and fix the naming so you don't have a strange name. When you're downloading for the first time, you won't have to do it. And now we can skip this session as we already have the app bundle. Let's just check it. What we have here, we have the folder .bundle with the contents and the XML file, and in the contents we have the logic. Here we have the logic through this DLL, the dependencies. It uses this design automation bridge .dll and the adding with all the informations about the plugin itself, right? Let's go back to downloads, and here we have it. Now we have our app bundle. Let's skip this session. Now let's go with .NET Core. And now we are adding the controller for our design automation logic, right? Now our sample will be able to check the information from the Forge services. So let's add this controller under the controllers folder. To do that, let's go under the controllers folder, right click it, select add controller, API controller empty, paste the name from our tutorial and what you are already used to do, delete the default content, copy and paste the content from tutorial until here, right? Here we have basically what's required for us to build this plugin. All right, plugins and app bundles, they exist in the context of the Forge application itself. And to reference a plugin or an app bundle, we need to specify a name for this app bundle, and we need to specify also a reference to our Forge app itself. So as soon as we are submitting a job on design automation, submit a work item, we need to specify, I need to go design automation, run a job against this app bundle under this Forge application, and this is the version of this app bundle that I want to use. Design automation and activities can have different versions. You can have the first version for development, second version for production, and so on. Everything can be described, right? So in order for us not to have a version specified as a number, we can define an alias for a version. In this case, for this sample, we are always using the most recent version, defined as the dev version, and we are using a reference for our Forge app through its client ID. We can also change this reference, and this reference is what we call the nickname. You can patch the nickname of your Forge app to anything supported. It just needs to be globally unique. So using the client ID, we know that it is globally unique. In here, we have definition for local bundles folder. We're going to store our bundles inside the bundles folder that will be available in the wroot project. Let me just check one thing. I think I missed one step right here. Oh yeah, the bundle that we downloaded should be available inside the bundles folder inside the wroot folder for the .NET. So we need to do that also. Let's go back. Now let's create under the wroot folder a new folder and call it bundles. And inside this folder, we are going to add our app bundle that we just downloaded. Let me add the existing item inside downloads. Let me change it to contain all files, and this is the app bundle that we just downloaded. Let's add it, and now we have our app bundle available. All right, everyone got it? After downloading the app bundle, it should be uploaded to the bundles folder inside the wroot folder. All right, going back, I just went through the nickname that you can patch, just need to be globally unique. We are using the Forge client ID. This is the local bundle folders, is webroot, and inside that the bundle folders, we are using path.combine for that. We are using as alias for our most recent version for the bundle as dev. When we create a bundle, it's going to be version 1, and we are going to call this version as dev version. If we update the bundle, it's going to be the version 2, and we're going to assign the alias, the dev 1, to the most recent version. This is the logic that's going to be used for this web application. All right. And we also need to specify the class for our SignalR hub. Through this class, that in combination with the connection ID available, we are going to send the notifications to the client side. That's not everything. Through this tutorial, all of the tasks that we need are divided for better understanding, and we need to be incrementing this design automation controller class. That's why we have this commented section right here. This is where we are going to add the methods. First one, it should retrieve all of the local bundles available. So you can just copy this content and paste it right here. This function is going to simply grab the files, zipped files that we have inside our local bundles folder, inside this folder right here. So we can add multiple app bundles, one for AutoCAD, one for Revit, multiple for Revit, everything. The second one is going to retrieve all of the available engines that we have. Let's add a space here and add our next method. And in here, as I said, we have support for 4 different engines, and for each engine available, each product available, we have multiple versions. So you can run your job against Revit 2022, against Revit 2021, Revit 2023, and all of those available. And this list is updated as soon as we release a new option. All right, so the way to check which versions are available is through this endpoint here, get engines async from our SDK. Now we have the app bundle, the endpoint to create the app bundle. This is a little bigger. Let's go through the process of creating an app bundle. All right, to create an app bundle, first of all, we need to check if the app bundle already exists or not. All right, and the way we do that is we are going to create the app bundle based on the name of the file, zip file name. We also need to specify the engine that we are going to use. This is defined on the client side. It's going to specify that. And in this case, in this application, we are going to add app bundle to the name of the file. So in this case, it will be update RBT parameter app bundle. This is going to be the app bundle name. To reference one specific app bundle from our service, we need to specify the qualified ID. All right, they are referred as the qualified ID. The qualified ID contains the nickname that you can patch, and in this case, we are using the client ID. The app bundle name, in this case, will be the name of the zipped file folder plus the app bundle, and the alias. Remember, in this case, we are using as alias, we are using the dev, a string called dev. We are always calling this app bundle as dev. So this here is a verification. We are comparing, we are checking from all of the app bundles that we have under our account, if we have any app bundle with this name that we want to create. If we have it, if we don't have it, sorry, we are going to create the first version with this name. And to create it, we need to specify the name, the engine, the ID, and also a description. All right. Then we are going to call the endpoint to create that bundle. And as a response, we are going to receive a URL. And a URL, this URL will be used to upload the actual content. On the creation, we are only making a reference to the name of the app bundle and description and engine. After that, we need to upload the actual content. The app bundle that contains the logic using the product API. This content right here needs to be uploaded. So this response is going to be stored right here, and then we are going to assign the alias for this version 1 that we created, right? This else is a second case where the app bundle is already there with this ID, so we need to update the version, create a new version. So we call this endpoint to create a new version, and in here we are specifying the alias as dev pointing the alias dev pointing to the new version that we just created. Here we don't have a reference to which version number it is because we don't know if we are updating the version 1, 2, 3, 4, so on. So we grab that from the response that we received, right? From this new version dot version right here. After that, either if we created a new app bundle or a first version, sorry, or if we updated the version, we are going to always store the URL to upload the content inside this method, this variable right here, new app version. And after that we know that we created the bundle and the alias, we need to upload the actual content. And this is what we are doing right here. Upload the zip with .bundle. All right, so this is taking care of the parameters required. The way it works is that the response passes some signatures required and also the URL. So right here we are sending the request with the zipped content and grabbing the response, ensure success status code. After that, we know that we just created the app bundle. All right, we uploaded the content. Now we have the app bundle ready to be used by to be referred by any activity. All right, after that, we also need to add support for add our signal, our hub, our design automation hub that is specified on the server side. And that's done through the startup class. We are going to add support for routing and for this endpoint for the hub that we need to use. So inside the startup, after the app.useMDC, we paste the content from tutorial, app.use routing, and to reference to the design automation hub that we have. This is just happening. This error is happening here because I specified a different namespace from the one used by our tutorial. Our tutorial is using the for sample namespace. So to fix that, we can, for instance, delete it and type control point and add using inside our application. It's just because the tutorial uses this for sample namespace. If you use anything different than that, you need to perform this step, right? All right, so everything is covered in this part, and now we should be able to check to see all of the app bundles that we have and all of the engines available on our application. Let's debug it. If you have questions, this is a good time. It is using a different port right here. I haven't noticed that. That will give us trouble. Let me fix that. Right here. We should fix this right here. Let's use this port 3000. All right. Do you have any questions about the app bundle? You can rename it, Tyler. You can rename it to match your project. Feel free to do that. It's just for the simplicity of the sample. So yeah, feel free to do it. If you compare to the .NET 6, we don't need to specify the namespace. So yeah, this is just a node framework. All right, if you go here, now we are able to check our app bundle. I only have the Rabbit app bundle and the engines. Of course, we are not going to run a Rabbit logic, Rabbit app bundle against our 3ds Max engine. So in this case, we will be using the Rabbit. I'll be using the Rabbit 2022. It is this code is still valid for Rabbit 2022, right? But as of now, I can't create the activity. We don't have the endpoint to create the activity. So we can click this button actually. That's going to be done on the last phase of our tutorial, all right? So far, hope so far so good. Do you have any question? Any other question? No? Okay, so see you, what do you think? We have only one step, one extra step, the creation of the activities and the work item. How many minutes do you need to go until here, to get here? Is 10 minutes good? 15 minutes? Continue with 10. So, all right, let's keep with 10 minutes. Sounds like a standard. See you in 10 minutes then. Thank you very much. If you have any questions, please use chat and Q&A. Start the recording. And now sharing my screen. And the presentation. Okay, this is the last part of this tutorial. Now we'll take care of creating the activity and submitting the work item responsible for actually executing the job against the input files that we specify, right? This is the tasks that we're going to cover now: the creation of activity and execution of the work item. This is an example of one activity. We are seeing the JSON containing the definitions of the activity. And as said before, the activity will contain a command line. The command line is executed by the engine that we have available. And in here we can see the engine path. In this case, I'll be using the Autodesk Revit version 2022. So we are going to run the Rabbit core console.exe, and we are also specifying an input parameter. This input parameter is defined right here. So for instance, in this case, we are going to download, so verb get. We have a description, the input Rabbit model file, Rabbit model. We have a true for the field required, saying that this work item can just run, only run if we provide this input. And we also are going to specify the app bundle. Sorry for that. The app bundle that we are going to use, that this work item, this activity is going to use. It is specified right here. In this app bundle, we have the whole ID of the reference for the app bundle. The nickname, in our case, it will be the client ID, the name of the app bundle, and the alias. On our case, we are always using dev. We can also specify additional parameters. This sample is using input JSON, and this input JSON is put together based on the parameters that we specify, the height and width. So this verb get, we are specifying required as true, saying that we need to inform these parameters to start the work item. And we also have the output file, verb put, meaning that we are going to upload this file to a URL that is provided, and the local name inside our sandbox of design automation. The local name is output file.rbt, meaning that inside our app bundle, we need to generate a file with this name. And this is going to be the file that Design Automation is going to grab and send you the upload URL. Last but not least, we have the description, and in here we have the ID for this activity. All right. Design Automation supports a few callbacks for your running your work item. First of those is the on-demand callback. On-demand callback is useful when you have uploading additional input files that needs to be added at runtime on your logic. All right. The blog that I shared with you has specifies a case where you can use on-demand callback to add more than one input for your logic, for your work item. We also have the on-progress callback. The on-progress callback is used by Design Automation approximately every 30 seconds, and it includes the ID of the work item for which it has been sent. It can be used to stop a work item if you see something that is taking too long or going not according to what you wanted. And last, that one we are going to use for the sample is the onComplete callback. The onComplete callback lets you know when the execution is done. As soon as the job is done, once more, we have the queue. When you submit a job, it's going to be queued. And then when it is going to be grabbed from the queue, it's going to download the input information, process your file, and then generate the output. As soon as it uploads the output file, it's going to send a message to the onComplete callback. And this message will contain the status of the execution, if it was succeeded or if it was failed, the log that was generated for this execution, and the times that it was enqueued, the time it was started downloading the input, the time it started it uploaded the output files. All right, it's really useful, and it's better than keep polling the work item ID to see what's going on. All right, let's go. Now let's create everything. First of all, we need to define an activity. Activity is, as it says here, is the specification of the action, and it can be referred to multiple work items. The work item is the execution. Activity is the orchestration of everything that's going to be done. First of all, we need to specify the engine attributes. As I showed to you on the JSON that I shared for the slide, we have a command line for a Rabbit file, for a Rabbit job, sorry. But depending on the job that you are going to specify, the command line might be slightly different. It needs to, first of all, it needs to make a reference for the executable, and it's going to change depending on the engine that you use. And also we can have a script field, for instance, and another differences. Let's copy this content and add it on our Design Automation controller. Copy to clipboard. And now we go on our Design Automation controller. The automation controller, add a space here and paste this content. This is taking care of is going to retrieve the proper command line depending on the engine that we select. In this case, we are going to select Revit engine, so we're going to return this command line right here. Right? Let me get this here. All right. Next step, we need to create the actual activity. There is a lot of things going on here. So let's copy and see what it does. Right, first of all, to create the activity, we need all of the information that I showed you on that JSON file. We need the engine that we are going to use. We need the activity name. We need the app bundle name to make a reference, and all of those, the activity ID and the app bundle needs to be complete, including the nickname, the actual name, and the alias for the specific version, right? Here we are defining the activity ID, just like we did for the app bundle. We are always using the nickname. In this case, is the client ID. The activity name will be the zip file name plus activity, and the alias will always be dev. All right. As we did for the app bundle, first of all, we need to check if we already have an activity with this ID specified. So in this line right here, we are retrieving all of the activities associated with this Forge app. And here we are checking if this activity is available or not. If it is not available, if we didn't create it yet, we are going to create here. So here we are creating, we are adding the engine attributes, which is the command line for the method that we just copied. This is taking care of the command line. We also need to specify the ID, the app bundles that we are going to use. In this case, we are using only one app bundle with the full name containing the nickname, app bundle name, and alias. The engine that we are going to use, the engine is specified from the client side. Remember, on the client side, we have an option to select which engine is going to use. We are going to pass that to the server side, right? And then we are going to specify the parameters. The parameters are the input file, the definition on the input file, the definition of the input additional parameter. In this case, it's called input JSON, and the definition of the output file, with everything specified. If it is on demand, in this case, we are not using on demand callback. The verb get for download and put for upload, if they are compressed or not, if they are multiple inputs or not, in this case not. And after that, we can call this endpoint to this method from our SDK to actually create the activity with these specifications that we defined, right? After creation of the activity, this is the first one that we are creating, sorry for that. It will be the first version. So we need to assign an alias for this first version of the activity. In this sample, we are always using the dev alias. So from this point, we can use an activity with our nickname, client ID, plus the name that we specified, dot the name that we specified, plus the alias, in this case, dev. All right, and this is going to be returned to our client side. In case we already have the activity, nothing needs to be done, because the activity already makes a reference to the app bundle that we are going to use. If you upload the app bundle, the app bundle is going to use always the same value that we specified right here. It's always going to use the dev alias, so we don't need to update the activity. If we update the app bundle, through the logic of this application, this activity will always be pointing to the most recent app bundle with the dev alias. All right, we also need to specify the endpoints to get the activities available. Let's add it here. It's used at first runtime when we call that list projects, list activities. Let me go there once more. When we call this prepare list, sorry, when we call this prepare list right here, get the activities. So we are adding this endpoint right here. And right now we should be able to create one activity through the method that we just added. So let's do it. Moment for my water. And if you have questions, the people here, what engine are you currently using for our product? What engine are you mostly interested? You can please drop it on the chat window. Inventor, we have lots of contents for Inventor also. Oh, people are quiet. Are you there, the other ones? All right, now it's listening everything. And if we go under our model, we can see our bundle that we just uploaded, and we can select one engine. Let me select the Revit version 2022. And now I can create an activity pointing to these resources. As soon as I create it, we can see the log right here. It is referring to this app bundle and the activity was creating. Now I can see my existing activity. As soon as I do that, my method is going to prepare the list once more and update my options with the activities that I have available, right? And with that, we take care of the activities. Now we need to execute the work item, take care of the work item. Work item, as already said, is a job that runs on design automation, pointing to a specific activity with a desired input and to generate a desired defined outputs. It is the execution of a job against an input file, execution of an activity against a input file. Let's see it through .NET Core. And now we need to increment these methods on our to start our work item. Let's add those to the design automation controller class. Let's add it right here. And this is taking care of generating the input URLs and also the output from design automation URLs. Before we jump into that, it's good to mention a change that we have on our platform. Let me upload it on our new link. Let me filter by Jaime here. If you go to this blog, this is really important. That's why we need to ensure that we use the most recent version of our API, of our SDK for Autodesk.Forge. Let me send it to the chat window. And what it is saying, this blog is saying, is that at the beginning of this year, we had a change on the way we do the binary transfer on our transfers on our platform. Since before this year, you had to go through RPG Gateway if you needed to upload or download files. Right now, we are granting access to directly the actual AWS bucket. We call it direct S3 access. And since we changed everything, we had some time with both of these methods working. The previous one through Gateway and the most recent one directly to S3 coexisting. From September 30th, we are only going to allow the most recent one. So a few changes are necessary. You need to do a few changes if you use the previous one. I guess that's not the case of the people from this tutorial, since you are beginning to use for the Forge platform. So that's why you need to always point to the most recent SDK. And we have all of the steps to upload and download files described here, and they are also covered in the SDK in a much easier way. That's what we are going to do right now, right? Let's go into the method for creating the work item. All right, first of all, to start the work item, here is where it begins. To start a work item, we need to provide this an automation, a URL that the execution, the virtual machine can use to download our input files. But where are our input files? In this sample, we are using a file, we are basing the job on a local file that we have on our machine. So the first step is make this file accessible by URL, by specific URL. And how we do that? Autodesk Forge uses AWS as platform, as infrastructure. So it means that we have buckets available. You can take advantage of Forge, your buckets managed by your Forge application to use as storage for your files. What we are doing right here is basically grabbing the file that the user uploaded and uploading it to a bucket. So as soon as we upload it to a bucket, it can be accessible by design automation, right? So first of all, the way the new method works is that we need to specify a upload URL, and then we are going to use this upload URL to upload the file that the user specified as input to this bucket, all right? After we upload this file, we need to complete the upload. This is done right here. So here we have the URL. We grab the URL from the response that we received, put the file that user specified as input in this line right here, and then we complete the upload. From this point, from this line, the file is available for us at our Forge managed bucket, right? After that, we need to generate a URL to download this file that is on our bucket. This is done through this line right here. And in here, we are specifying a minutes expiration. This minutes expiration says that this URL is going to be valid for 60 minutes. So Design Automation has 60 minutes to download this file, right? And after that, we are just going to return the URL that Design Automation can use. These are the steps to prepare the input file. You grab it from a local, upload it to a bucket, and then generate a signed URL so Design Automation can grab the input from that bucket. Now we need to also prepare the output URL, the URL that Design Automation is going to use to post a file on our bucket. We are again using based on a specific bucket key, and we have an object key, which is the key for the file that we are uploading, and we are going to generate a URL to upload this content to this object, right? Once more, we are specifying how many minutes this URL is going to be valid. We are specifying in this case 60 minutes, and then we are going to send this URL, return this URL to our we use this URL, send this URL as a return from our method, right? And in here, everything put together to start the work item. Starting the work item, this application also needs some input parameters, the parameters that are going to be used to modify our design. So in here, we are reading these parameters from the input that the user specified, and passing that to design automation as JSON data, as a data in JSON format, all right? We also need to retrieve the token. We are going to always use the internal token. Here we are grabbing the path, the file from the client side and saving it on server. And right here, we are taking care of generating the input URL and the output URL. But before that, we need to ensure that the bucket exists. This sample is using a bucket that's with the bucket key specified as the nickname that we provide, in this case, the client ID, and we are adding to this client ID the dash design automation. Right? Specifying that this bucket is going to be used by design automation itself. This try catch here is pretty simple. We are just going to try to create this bucket. If this bucket already exists, it's going to raise an error. So we are going to follow the sketch case here, and we don't need to do that. We just ensure that this bucket actually exists. After that, we have the input file name specified. The input file name that we are going to define for this case, we are adding the date time that we have, so we don't have duplicates for files with the same name if we upload those with on different time zones. And we are going to call the method that I just went through to prepare the input URL. Here we're going to retrieve the input URL and prepare it for the work item. And after that, we are going to do the same for the output. We are generating a random named file, sorry, not random, a file name with the dates now added, so we don't have duplicates. The verb in this case is put, and in here I have the specifications for our work item. I have the input file URL, the JSON will be a JSON data containing all of the information. One point, the JSON data is not a URL to download a JSON with all of the information. We are simply passing the parameters with this header right here, this content type right here, data application JSON. This is good enough to pass the parameters. The output is passed right here also, and we are also specifying the onComplete callback URL. The onComplete callback URL will point to the ngRock. This is the part that we use the ngRock. We specified it on the first session, yeah, and we only use it now. How this is going to work? As soon as our job is done on design automation, it's going to call the callback that we specified right here. So through ngRock, we are tunneling this URL right here. So design automation is reach this URL, and it's going to point to localhost port 3000. And from there, we are using this endpoint right here, design automation API callback, right? With these query string parameters. We are about to add this endpoint. It's not added, but it's good to inform that here we are taking advantage of Forge Webhook ID, Forge Webhook URL, the browser connection ID. Why do we need the browser connection ID? We need the browser connection ID to send a message to the specific client that started this job, right? In the output file name. So after that, we grab from the bucket the correct file that got uploaded. If we have multiple instances running at the same time, we have multiple files. So we need to know which one that we need to grab and pass to the right end user, right? Now the only thing is missing is this endpoint used by design automation itself. And this is covered right here. Right here we have our endpoint, our callback. Let's add it right below our start work item input class. And what is doing, what this endpoint is doing. As soon as we receive the notification from design automation containing the whole body with all of the information, we are going to obtain from that the client ID and the name of the file that was generated by design automation. Through the usage of the client ID, the connection ID, sorry, the connection ID from server side to client side, we are going to send the incomplete message. The incomplete message is going to tell that our job is done. And after that, we're going to take advantage of the response that we receive from the body to show the log from our execution to the end user, to the client side. And last but not least, we are going to use the generate a URL so the user can download the output data. And this is done this way right here. It's going to, this URL is going to be valid for 15 minutes. So as soon as this job is done, the user can see a URL, can access the file for 15 minutes. After that, he'll need to go through his bucket to have access to it. This line right here is taking care of the payload. Yeah, this line right here is take care of the log, to return the log, read the log, and send it to the client side, right? All right, let's go to it. And one more endpoint that got missing is to clear the whole account. Clear the account is just an endpoint to remove all of the app bundles and activities that we have defined. If you got lost of the activities that you have, or you need to go from scratch, you can call this endpoint and it's going to remove basically everything that we have, right? Now we can run and debug our application. We have everything ready. We just need the sample files. As this application, this bundle has a specific logic, you can reach this address right here to download one file. I already downloaded the Revit sample file, but feel free to go. I'm not sure if you're using Tyler, if you're using, for instance, Inventor, so feel free to grab the file from here. So let's start debugging, and I'm just going to add a breakpoint on our callback to see everything as soon as our job finishes. Almost forgot my water. Let me add some random value then. 5 and 7 here as input. Now I already have my activity that we created in the last session, and I need to choose my input file. I have it under downloads, Revit sample file right here. And now I can start my work item. Work item started, it returns to us, this application returns to us the work item ID. Every work item executed has a specific ID that we can use to reference and check the status and everything. Through the command prompt with the ngrok, we should be able to see a result as soon as we receive a notification, as soon as our job finish its execution. Does anyone have a question? Any question? We can also use this automation as all of our APIs through Insomnia. Oh, it already started. All right, so our job is done, finished. So it reached our callback, and now we have all of the informations available, and we have the file available to be on our bucket. Our file generated, ready to be completed on our bucket. First of all, we are sending a message to the client side. We can see it right here with the JSON payload from this callback. It says the status of our work item it was a success. We have the report URL. We can use this URL to download the logs generated, and we have all of the time. The time it entered the queue, the time the download started, the instruction started, the instructions ended, and the uploaded ended. And we have also the number of bytes downloaded and uploaded. And here we have the work item ID. All right. Another thing that I didn't mention, the way this this new method for upload works is that, first of all, we need to generate the upload URL. Then we use this URL to upload the actual bytes of the file. After that, we need to call complete upload. The way this should be done through design automation is that inside this onCallback method, after we receive the notification that the job is done, then we need to complete the upload for our object, all right? And this is done through this line right here. This is going to complete the upload of our file. As of now, it's not available in there. So, and after that, we are going to generate the URL. Now we are grabbing the data from the log, and we are going to send this data from the log to the client side. In here, we can see the whole log for the execution of this work item. We can see how it works, how it worked. It started right here, and then it started the downloading phase. Started downloading the input, ended the downloading. It was really fast, as you can see. We can see when it started to run the Rabbit Core Console against our logic. If we added console.writeLine, it would appear in these lines right here. And you can see the whole execution until the finishing of the job, right? It is quite complete, the log that we have. Now we need to grab a token and complete the upload. And then we are going to send the URL so the end user can download the resulting file, right? Console.write congrats, and we should be able to check the download URL. Let me just see. We should be able to see the download URL. Let me just check through client side if I missed something. Was there any error? Oh, disconnection. Probably due to the breakpoint, it was too much time, so it broke the signal or connection. Let me do that without the breakpoint. Let me refresh this page so we have another connection. All right. WebSocket connected. Let me add 7 and 7 here. Choose the input file. Grab its sample file. Signal gets broken if we use a breakpoint and wait for a long time. Sometimes it breaks the workflow. Now let's wait and without debugging and see the results coming along. So far so good. Any question? Working for you? Okay. Yeah, you need to remove the breakpoint. All right, now it's done, and now we have the download. All right, and if you click here, you should be able to download the resulting file. I can open it on Revit. You can open it also using the previous samples that we built, the one from the first day of the tutorial, or the one from the second day of the tutorial, or you can use viewer.autodesk.com. Let me sign in. And let me upload a file, select file, from downloads, this one that we just downloaded, no more files. And it's going to upload the file, translate it using model derivative, and then we should be able to see it using viewer, just like we did on our application. You can also, if you want to test design automation, you can also test with Insomnia, a tool such as Insomnia, and for webhooks for callbacks, you can use webhooks.site. Let me reach it. It was saved right here. It's webhook.site, not webhooks. Let me just take it here. Here we can see our window. Just resize it. And if you go under here, it's webhook.site. This site is really good for debugging because you can specify a callback to this site, and in this case, as you are debugging, you wouldn't need to use ngrok, for instance, and you can make your calls through Insomnia. So either way, feel free to use the one that you prefer. Just another option. All right. So that was the goal for the sample that we built today. I have just one more comment, one more content to show on design automation. Let me just reach it here. Autodesk Forge Open Network. We have Open Network in preview. This is a recent change on design automation. As I said, design automation works on a sandbox where it has access to the files that you describe it, that inputs that you describe it, it generates the outputs and communicates using the URLs that you provide. We have this function on preview and it's about to be released publicly. And Open Network basically lets your design automation engine, your design automation work item, call HTTP requests from this execution, from the runtime. So you can have inside your app bundle some code using, for instance, HTTP client or REST sharp to call an endpoint outside of the system, outside of the using more than just the Revit API, for instance. As of now, it is on private beta. If you want to test it, you need to have an empty account, an empty Forge app, just with a nickname, and then send a message to us. But it should soon be available publicly. All right. Let me post the blog right here. And let's continue with the slides presentation. And that's it, done. If you need more help, you can always count on us through Stack Overflow and using the proper tag depending on which API you need help with. You can also go through support. You can schedule a meeting with us. You can send us your doubts, your questions through forge.help@autodesk.com. And after this event, we have a few other contents and other events that you can take advantage of. We are going to send you an email with the recording links on YouTube. The links to the slides, use it in this presentation. We have a survey and we need your feedback. How is the format for you? How many minutes would you expect between the sessions? What can we do to improve this training? Should we have a different content on how can we make this experience better? And after that, if you want to take your newly acquired skills to the next level, you can take advantage of different events that we have in different contents. Our blog, as I shared a few blog posts with you, they have lots of contents on how can you use multiple inputs, what are the news on our APIs, what we have that is new. We have the lightning talks. We have lightning talks specifically for each of our products, and we have a program that's called Accelerator. The Accelerator program is just like a hackathon. It works for 1 week, and during this week, you have 24 hours of support. And this support, you can count on the whole team of developer advocates. If you go under here, community, all events, you can check the accelerators is right here for the accelerators. The upcoming one is the Kansas City, is a virtual one, so you can join from anywhere in the world. You just need to have a proof of concept to work with, and then you submit your registration to work with us. We have a whole week of work from Monday to Thursday, and on Friday, the different teams are going to expose what they did, right? That's not everything. Next week, right before Autodesk University, we have our hackathon. And this is actually a hackathon, so it's like a competition where you can choose between any of the available challenges to build your solution using the Forge platform. And if your solution is selected and you win, you can win a really cool prize. The cool part of the hackathon is that the winners are going to have a showcase on the Autodesk University, and it's going to be available for the whole world on our platform. All right. So we have challenges for connecting with ACC, to aim for sustainability challenges, design automation, they won't cover today. Task automation is a state of mind, gamification using the Forge platform, and so on. We just released a blog on the hackathon, and these are the prizes that we are going to have for the winners. Cool prizes, right? I would like to win this Nintendo Switch OLED if I participate, if I were participating. So it's really good. It's really useful. You have the support of the whole team during the next week if you'd like to join us. And also, If you go under events, we have some extra content. If you need assistant, you can schedule a one-on-one call with any one of us. If you select this option, you'll be redirected to our Calendly. And from here, you can select any one of us. If you click the right name, for instance, my name here, you can go here and select schedule some time to talk with me for 30 minutes. And you can choose between the available time zones that you have, right? And this will just schedule some time directly on our agenda. And we also have the coffee break. Every 2 weeks, we have a virtual coffee break happening globally, where we have our developer advocates sharing the news, sharing insights, and you can submit your questions to be answered on real time, right? That's what I wanted to share with you today. I hope you enjoyed this bootcamp, all of the sessions. And with that, I'd like to appreciate you for your time and ask you for your feedback on our service. And you can count on us on each of these events, or even through email or calendar. We have lots of possibilities, right? Thank you very much, and see you around.